Hello, welcome to this tutorial in which I'm going to have a look at another examination style question on circle theorems. In this particular one, A and B are points on the circumference of a circle, center O. BC is a tangent to the circle, AOC is a straight line, and the angle OCB, this one here, is given as 35 degrees. And we're asked to work out the size of the marked angle X, which is this one here, and to give reasons for our answer. I'm just pausing. The diagram is not drawn to scale, incidentally. I'm just pausing for a second or two to give you a chance to have a think. Okay. Since BC is a tangent, we should know that tangent and radius meet at 90 degrees. OB is a radius and BC is a tangent, so the angle OBC must equal 90 degrees, this one here. So we can write the angle OBC is 90 degrees, and the reason is tangent and radius meet at 90 degrees. So what's the next move? Well, since in triangle OBC we have two angles there already, it seems logical to find this one here, which is BOC. So we can write BOC equals 180 minus 90 plus 35. The reason is that the angles in a triangle add up to 180 degrees. So it's 180 minus 125, which is 55 degrees. Incidentally, if one angle is already 90, then we expect the other two to add up to 90. So it's probably quicker to just say BOC is 90 minus 35, which is 55 degrees. The reason is still the same. Angles in a triangle add up to 180 degrees. So we can write in here that that's 55 degrees. So, what's the next move? Well, there are three possibilities that I'm aware of. There might be more. They're just variations probably. And the first one I want to do is related to an angle at the center being twice the angle at the circumference of a circle. So, if I could just label this point here D, we can see that BOD is an angle at the center. It's facing this arc BD, which is the minor arc. If I join B to D, you might be able to see it better. So, which angle of the circumference is also facing that arc? We say it's subtended by the same arc. Can you see which one it is? Well, it's the angle BAD, this one here. So that 55 degree angle is twice the angle BAD. So we can write BAD is 55 divided by 2, because it's half of it, which is 27.5 degrees. So we can put in here 27.5 degrees. Well, we're nearly there. What type of triangle is the triangle AOB? Well, it's an isosceles triangle because OA is a radius and so is OB, so they must be equal. That means two of the base angles must be equal. And the angles that are equal are the ones opposite the equal sides. So the 27.5 is opposite OB, and angle X is opposite OA. So we can write that X equals 27.5 degrees. Okay, and the reason is AOB is an isosceles triangle. So what's the next method? Well, I've already drawn the diagram and I've put in the angles we've already found. Okay? So, if OA is equal to OB, then we know that this angle here must be x. Now, if we look at the triangle AOB, and we've extended the line AO to the point C, we have created an exterior angle, which is 55 degrees. And that exterior angle is equal to the sum of the two opposite interior angles. There is a video tutorial on the exterior angle property of a triangle, or the property of an exterior angle of a triangle. Well, both of those angles are x, so we can write that 2x equals 55 degrees, so x equals 27.5. Excuse the writing. Okay, so the reason is exterior angle property of a triangle, or the property of an exterior angle of a triangle. Right. Well, you could argue that we don't need to know that. We could find this angle here, y, which I'll call y. AOC is a straight line, so y plus 55 add up to 180. So angles in a straight line, when they share a point, the vertex in common, they have a common vertex, they add up to 180. The reason straight line would do. So subtract 55 from both sides, you get y equals to 125. But the angles in the triangle AOB add up to 180. So we can write 2x plus y, which is 125, equals 180 degrees. Subtract 125 from both sides, you'll get 55 degrees. So divide by 2, you get 27.5 degrees. Incidentally, the angle y, which is angle BOA, is an exterior angle to the triangle BCO. You've extended CO. So a quick way to find y is to add 90 plus 35. I hope that doesn't confuse you. It's the exterior angle property again. Okay, finally, with those put in on the diagram, the next thing is to say that OB is a radius and OA is a radius, so they're equal, so this angle here must be x. Okay? If we now consider the triangle ABC, this angle here is x, this angle here is 35. I'll just put the labels on A, B, C. And what do we know about the angles of a triangle? They add up to 180 degrees. So what's this angle ABC? Well, that's x plus 90. And if the angles in a triangle add up to 180, we can say that x plus 90 plus 35 equals 180. So 2x plus 125 equals 180. Subtract 125 from both sides, we get 55. Divide by 2, we get 27.5 degrees. Well, I hope you found that useful. On to the next one. Take care.